Chandran sir. Sandeep Chandran sir has completed his bachelor's in IT from Cochin University and master's in system analysis and computer application from 𝐈𝐧𝐼𝐻. So he currently works as assistant professor at 𝐓𝐵S College of Engineering, Kasaragod. So he has started his teaching career in 2007 and has handled various posts and have taught courses ranging from data structures to programming in C, C++, Java, and Python. He has got 2 journal publications and 3 conference publications so far. So it's indeed our privilege to have Sandeep Chandran sir join us. So on behalf of SF and all the attendees who have joined today, I welcome you, sir, to begin with today's session. Over to you.
Okay. Okay, our topic today is pointers. It's a one of the difficult topics people students are saying about programming, especially when you are studying C or CBP. So this is just a basic starting PPT presentation. I think I'm not covering much details related to your syllabus. It will be covered. Okay. So first part we will go through the what is a pointer, what is the use of a pointer. So I will try to reduce your problems, your confusions regarding pointers. That's the main part. Then I will go to the something related to object-oriented programming, how pointers are used in object-oriented programming. So that's the 2 topics we are going to cover today. Okay. First thing. Okay. So first thing, what's a pointer? That's the first question. Okay, pointer is just a variable that hold memory address. Normally we create variables. Variables are created for storing values. But pointer is a special type of variable that is used to store address. Okay. So that's the definition of a pointer. What is a pointer? It's clear. It's just a variable. It's used to hold the address or memory locations. Okay. Let's see an example. Okay, I have a variable int a = 5. You're declaring a variable a = 5. What happens in the memory is that memory will have some address locations. Okay, if I declare int a = 5, what happens is that a will be pointing to some memory location, and suppose I'm saying it's a memory location is 1002. Okay, and the value 5 will be stored in that address. That's the thing happening in normal declaration of a variable. If you declare any variable, that variable will be pointing to the address location, and the value corresponding to that variable will be stored in that corresponding address. So that's the first part. Next, we will talk about pointers. So pointer, I told you, pointer is just a variable used to store the address. Okay, so I'm going to create another variable. Its type is not integer, its type is pointer. I'm going to create a pointer variable, pointer b. To that, I want to store the address. Okay, I want to store the address 1000. So simply I will write pointer b = 1000. Means b is a variable which is used to store the address. Normal variable is used to store the value, but pointer variable is used to store the address. That's the thing. So pointer. So I'm storing pointer b = 1000. But normal case, when we are declaring int a = 5, we don't know where it is being stored. We don't know the address of the variable. Okay, so in order to get the address, we will use this AND operator. So if I want to get the address of a, I simply want to type AND of a, or I want to simply write AND of a, I will get the address. So I'm creating another pointer variable, pointer c, and this pointer c want to store the address of a. The first example, I purposefully given the value of pointer b as directly as the address 1000. Here I'm not giving it directly. I'm saying, okay, I want pointer c should store the address of a. For that we can write like this, pointer c = address of a. That's the thing happening in the memory. A is a variable, it's storing 5. B is another variable, it's storing the address of 1000. C is another variable, it's storing the address of A. That's 1002. Next, we will talk about this asterisk operator. So you have been seeing this star operator so many times. So okay, what's the main purpose of star operator? It's for multiplication. Simply we will use multiplication, star indicate multiplication. But in the case of pointer, we use star for two purposes. Okay, if I am writing like this, int d equal to star c, it means that get the value at the location pointed by c. That's the meaning of star c when we are writing in the right hand side. In d equal to star c. So what mean is that I want to, d is a variable. I created a variable int d. Automatically memory will be allotted for that. It is pointing to the address 1000. Okay. In d equal to star c means it will come, c is a pointer. C will come to the address location c. Okay, C contain an address 1002. In 1002, we will go to 1002 and we will check what is the value of that. It's 5. So that will be stored. This star operator is used to get the value of a location at location pointed by C. It's a new thing that is used. Normally star is used for multiplication, but when we are dealing with pointers, if you write star C simply, what it means is that C will we will go to the location C. So the C is in the location 1005. C is in the location 1005, and we will check the what's the address of that. Okay, C is a pointer, so C is its address is 1002. We will go to that location. In that location, what is the value? So star is used for getting the value at location pointed by a variable. That's the first use of asterisk operator. Another use, I'm simply writing this int star e. This star is used to create a pointer variable. In the first example, I purposefully written it as pointer b. But we don't have such data types. Pointer data type is not there. So we want to create a variable, okay, which should store the address. Normally variables are used to store the value, but here I want to store the address. For that, I will use the star operator. Again, star operator in star e means create a pointer variable e. So e will be created at some location, and this e can store an address, some other address. Three uses. Normally star is used for multiplication. When we are using the right hand side, it means that along with pointers, star c, if you write star c, what means is that we will get the value at that particular location. Okay, we will get the value of the particular location. And if we declare a variable in star e or in star p, then that means it is an integer variable will be created, and to that variable we can store the address of an integer. That's some three operations of star. Okay. Another example. Okay, I created a pointer variable. This is a pointer variable. It's a normal variable. Okay, normal variable is used to store the address of value 50. Okay, a normal variable have an address 1001 and it contain a value 50, and I'm going to create a pointer variable ptr. So ptr will contain address. It will never contain a value. It will only contain the address. So 1001 is the address of this variable that is being stored here. Now automatically a variable will have an address. Its address of the pointer variable is 1047. Okay. Let's go to the declaration of a pointer variable. Okay, so this is the format. First of all, you have to type the data type, then star variable name. This is the format for declaration of a pointer variable. If we declare int a, what it means? It means that a is a variable, integer variable. We can store the integer value. But when we declare int star a, it means that a is a pointer variable and can store the address of an integer variable. That's the meaning. Like that, float star b. What it means? B is a pointer variable and can store the address of a float variable. So I think it's clear. So we will go for an example. So here I have created a variable 50. Okay, I want to create a pointer variable. So we don't have a pointer keyword. For that, we will use the same integer variable along with a star operator. It means that it's a pointer variable. Okay, in star ptr. PTR is a pointer variable. Now I want to store the address of this variable. Okay, I don't know the address, but using this AND operator, I will get the address. Okay, PTR equal to address of that particular variable. So PTR will have the address of the variable. Okay, next thing, I want to print the address. I will simply print the value PTR. Then I will get the address of that particular location. In order to get the value, I will use again star. What it means PTR, we will go to the particular location PTR. PTR will have an address of the variable VAR. So it will go there and get the value. So value 50 will be returned. Okay, we will just run this program. Okay, this is example 1. I am using a GCC compiler in Windows. So some difference will be there. Example 1. C++. I will use C++ compiler. Example 1. For Windows, we will use /a.out. It will not work. For that, we will use a.exe. Okay. So address of the pointer is 0x72fe04. That's the address, and the pointer have the value 50. So these two things, it's clear, I think. What's the use of star operator? How it is being used. When it is used on the right hand side, it means a different meaning. When it is used along with the declaration, it means a different. When it is used along with the declaration, it means that we are going to create a pointer variable. And when we are simply writing star a, what it means is that getting the value at that particular address. That's the meaning of that. Now we will go for pointers and arrays. What's the relation between a pointer and an array? Okay. So array, you all know, it's a collection of contiguous memory location and can store similar type of elements. Okay, I'm going to declare a variable, a array, a of 5. That means 5 memory locations will be allotted, and this a variable will be pointing to the first memory location. And each location is identified by a of 0, a of 1, a of 2, a of 3, a of 4, like that. It will be allocated like this. So this is the structure of an array. So when we are creating an array, it will be looking like this. A is a variable, and this variable will be pointing to the first location, and each location will be identified by like this. Okay, let's see an example. So here I created an array of size 10, A of 10. Okay. Next, I want to print the address of the first location. Just want to print the address of the first location. So how will you get the address of the first location or any location? We will use the AND operator. Our first location is identified using a of 0. Okay, so automatically we will write cout and of a of 0. It will return the first location address. We will check what will be the output of this one. Cout a. What will be the output? A is actually pointing to the first location. In the figure, it's clear. A is a variable. A is a array variable, and that is pointing to the first location. So that means this A, if we print A also, we will get the first location address because A is pointing to the first location. So instead of writing and A of 0, we can use, if we write A also, we will get the same memory location. Okay, I want to print the next address location. Normally, I will go for and A of 1. That will be the address location of the first location. If you simply write a plus 1, also you will get the same address. We'll see the output of this. So same thing is happening. So first memory location address is 0x72FDF0. Same thing I printed using two methods. One directly by using AND of A of 0. Another by simply location is an array.
Hello, sir.
You move one location, you will get the second location. So A plus 1 location. So next location is 0x72FDF4. 0x7 to FTF4, the same thing I am printing. So instead of writing AND of A of 0, AND of A of 1, we can simply write A plus 1, A plus 2. Like that, we will get the address. So here I created an array with some values, 10 values I stored. Okay. Next, I want to print the array contents. For that, we will use we will use a for loop. Okay, we will write the values. Cout A of I, we will get the values. Okay. Same thing we can get using writing like this also. A plus I star A plus I. Why it is? Because A is actually pointing to the first location. If you want to get the address value of first location, normally we will use A of I. If I simply write A is pointing to the first location and A will get the first location address. Star A will get the corresponding value. That we discuss later. Star A is used to get the address, get the value at that particular location. So star A will get the first address, first value. Like that next value. Next value normally we will use A of 1. We will get the next location. So same thing we can do. We can move to the second location by A plus 1. So A plus 1, I want to get the value, then I will use star A plus. You will see the example. Example 3. Example 3. So same thing is happening. Array elements are 5, 6, 7, 8. Some numbers are there. Up to 10. 10 numbers are there. This is the array elements. Same array elements is being printed again using the pointer. Pointer not array variable, but instead of I am using instead of A of I am using A plus I, because A is a variable that is pointing to that particular address location. Okay. So from this example, what we can conclude is that AND A of 0 is equivalent to A. So instead of writing AND A of 0, you can simply write A. And A of 0 is equivalent to star A. If you want to get the value, you will use A of 0. For that, we can simply use star A. Like that, and A of 1 is equivalent to A plus 1. And A of 1 is equivalent to star A plus 1. Both are same. So what I want to say is that pointer and array are not same, but we can say is array name is converted to a pointer. This array name is being converted as a pointer. So instead of array name, we can use a pointer. That's the main. But instead of array name, we can use pointer variables, because array name is being converted as pointer variable. So array name is acting as a pointer variable. Whatever operations we are using in pointer variable, that we can perform using arrays. So that's the relation between pointers and arrays, almost same. So whenever we are passing something to a functions like that, we can use either array or a pointer. Both are same. Both are not same, but actually array name is being converted to a pointer. It is acting as a, because array variable is being pointing to the first location. So if we increment by 1, we will get the second location. Increment by 2, third location, like that. So this array variable, array name, is acting as a pointer. That's the relation between pointers and arrays. Okay. Next, we will talk about functions and pointers. I think we can break here and we will ask some questions. That's the first part. Hello?
Yeah.
Is there any doubts?
Sure, sir. If any of the attendees are having any doubt, please do post them in the Q&A tab. It's available at the bottom of your screen, right next to the chat icon. So we have got a question.
Okay.
Int d equal to star c means what is the value that stores as d?
Okay. What is saying? Int b equal to star c.
C.
What
So what would be the value that gets stored in d?
Okay. So when we are writing star C in the left side, what it means is that we will go to the address location C. Okay, C will have an address location. C will be a pointer. Okay, C, we will go to that address location and we will see what in that location what it contains. I will explain like this. We will take this example. Okay, in D equal to star C. What it means is that I want to get D have to store some value. What the value? So star C means it will go to that address location C. C is pointing to some address location 1005. Okay, 1005 will contain what? It will check. It will assume that this is a pointer variable. Okay, C. Then we will go to this location. It's 1002. It will not return this 1002. Instead of that, it will go to the 1002 address and get the value. Means star in the left hand side means get the value at the location pointed by C. Get the value at the location pointed by C. C have the address value. C have the value of 1002 and get the value of that. 1002 contain what? It will be returned. It will be stored. 5 will be returned to D.
Okay, sir. Sir, Athira Vishwanath is asking, int ampersand R is equal to N. What does that mean?
Int
Ampersand R is equal to N.
Ampersand R equal to N. That we will discuss later. I think we have not reached that.
Okay.
We are not reached up to this. Okay, we have said only two things. What's the use of star operator? If I write int star B, it means it's a pointer variable. I'm going to create a pointer variable. Next thing, that means P will have no value. It will contain an address. So next thing is I want to get the value in that particular address. For that, I will use int Q equal to star P. What it means is that P will have an address. In that address, what it contains, it will be returned and stored in Q. That's the truth. Clear, I think.
Yes, sir. Yes.
Okay. Shall we continue? Or?
Yes, sure, sir. Sure, sir.
Okay. So next thing. Next thing we will talk about functions and pointers. What is the relation between function and pointer? Okay. So before talking about that, just talk about argument passing. Okay. In the case of argument passing, we have two terms, actual parameter and formal parameter. A parameter passed by a function. I'm a caller. I want to call a function in somewhere. I want to pass some values. That is the actual parameter. Then that value should be stored there, and in order to process, that's a formal parameter. Parameter received by a function is called the formal parameter, and parameter I have created for passing, that is the actual parameter. Parameter passed to a function is called the actual parameter, and the parameter received by the function is called the formal parameter. Okay. So we have, I think you have studied about pass by value. In the case of pass by value, we are passing a copy. In this parameter passing method, value of the actual parameter is copied to the function's formal parameter. It has been copied, and two type of parameters are stored in different memory location. So any change made inside the function is not reflected in the parameter. We'll see the example. So pass by value means simply we are passing a copy of that value. I created a value int a equal to 5. I want to pass that to some other person. So I will be passing only the value. Okay, it will be passed, and I'm going to store it in int b. Okay, then b will have the copy of this a value, and a is called the actual parameter and b is called the formal parameter. Okay, let's see an example. Okay, we will take the example of a swapping. So I have created an initial memory status just like this. Before that, okay, I created a variable. Before that, we will see the example. Example 4. So it's a typical swapping example. Okay. This program started, created two variables, p equal to 5, q equal to 6. Two variables are there. I want to pass this value to a function called a swap. So I'm going to pass this one values 5 and 6 to this function swap. 5 and 6 is been passed to the function, and to the A and B value will be stored. So only the copy of 5 and 6 will be copied here, 5 and 6. And this P and Q is the actual parameter, and A and B is called the formal parameter. Okay, so 5 and 6 is been copied, and it is been stored in A and B. We performed the swapping. A value has been changed to B and B value has been changed to A. But A and B will have a different memory location. P and Q will have a different memory location. So we'll see the example. So I created two variables P and Q. I'm going to store values as 5 and 6. Okay. The address of the location is 1000 and 2000. So I created another two variables A and B. Address location is 3000 and 4000. Okay. So what I did is that I copied these values and stored in A and B. 5 and 6 is been copied to A and B. Its address location is 3000 and 4000. We performed swapping operation. So at the end of the swapping operation, what will happen is that A and B will be interchanged as 6 and 5, but still 5 and 6 is still, it's not changed, it's not swapped. So that's the main disadvantage of call by value. The actual value, the value of the actual parameter is not changed. Only the formal parameter value is being changed. That is called by value. Okay. So next thing, call by reference. So what it means? So actually, our problem is that the actual and the formal parameter is pointing to different memory location. Here, P and Q is been pointing to 1000 and 2000, and A and B is pointing to 3000 and 4000. That's the main problem. So what we want is, we want both, in the case of pass by reference, both actual and formal parameter refer to the same location. Okay. So any change made inside the function are actually reflected in the actual parameter. So that's the technique that we are going to use. We will be pointing these variables to the same memory location. Okay. This concept, actually, you have studied that in this concept, call by value and call by reference, will pass by reference in C. But there's slight difference in CPP. Okay. So we will see an example. So this concept, pass by reference, can be implemented in two ways in CPP. So first technique we will go for this example 5. Let's see this. So I created two variables P and Q. Again, same variable P and Q. And I'm going to pass that value to the function. Again, swap P and Q. It's been passed. But in the swap function, I'm using another thing, int and of A. Till now, we have not used and in like this. Inst and of A, inst and of. What it means is that it just renames P and Q. Actually, A and B is pointing to the memory location P and Q itself. And what and A means, it's just aliasing, it's just renaming A, P and Q. That means A and B will have no variables. It is a variable, but that is pointing to the same address location of P and Q. So actually this A and B is pointing to the memory location of P and Q. So whatever we change, it will be reflected here also. That's the first thing. So and A means it's just we are creating a alias name, or we are renaming the variable. In pass by reference, we are creating another name for the same variable. For renaming, we use this AND operator. Okay. The alias name to be initialized during declaration. That's a basic condition. So I'm declaring a variable int A equal to 5. I want to rename that to some other variable. Okay, I want to call using B. Then I will use int and B. It's an error because it should have a value. It should be declared like this, int and B equal to A. That means A is being renamed as B. So using B, if I make any changes, that will be also reflected in A. That technique is used in CPP. That's the first technique in CPP. So pass by reference, is using aliasing. Aliasing means we are just renaming the variable and using that. Okay. And B. So we will see example. Here P and Q has been declared 5 and 6. A and B are two alias names, and A and B. That A and B will also pointing to the same address location 1000 and 2000. It's not pointing to different memory location. It will be pointing to the same memory location. So what happens is that I copied the value 5 and 6 to A and B, but A and B is alias of A, P and Q. So I made changes to 6, 5. It will be automatically affected the actual value. So that's the meaning of AND B. So that's the first technique. Pass by reference using aliasing. Pass by reference normally refers to aliasing. We will be using this concept is not available in C language. It's available only in CPP language. And this AND operator can be used. That's by pass by reference. First method. Next thing, pass by pointer. So instead of creating an alias name, I can use the address. Why should I use alias name? That's the concept of pass by pointer. Here both actual and formal parameter refers to the same location. So any change made, such the same thing. Concepts both the same, but only thing is in the pass by reference I will be using the alias name. Here I am using another memory location. Okay, we'll see the example. Pass by pointer. So here P and Q is there. Instead of passing P and Q, I am passing the address. Okay, I am passing AND of P, AND of Q. So if I am passing the address, it should be accepted by a pointer. So I have to create a pointer variable. So a pointer variable will be created in star A and star B. Two pointer variables will be created and it will be stored. It will be swapping star A, temp equal to star A. What do you mean? We will get the value of this location. A have an address of B. P will have the value. That value will be copied to temp. Then star A equal to star B. What it means? Star B value is being taken. It will be an address and we will get the value of that. Okay. That value will be copied to star A. Star A means its value has been changed. Then star B equal to temp. Again, it has been copied. Actually, this A is been pointing with two different memory locations, but it's a pointer. We'll see the example. So same thing, P and Q is there. So instead of I am creating 2 pointers, I am passing the address of P and Q. So I need a pointer. So I created 2 pointers, star A and star B. Address location is 3000 and 4000 itself. And it is been passing the address of P and Q. Both address of P and Q is been passed. Then I am performing the swapping. Swapping is performed here. It will be changed. Actual parameter is being changed to 6 and 5. So that's a basic difference between 3 things are there in object-oriented programming. CPP, we have call by value, call by reference, call by pointer. Call by value, simply we are passing the copy. Okay, so any change made in the actual parameter, any formal parameter will not be affected with the actual parameter. So we need a call by referencing technique. Okay, call by reference means we are aliasing the name. Name is being aliased. That means it is being renamed. Same variable will be pointing to the same location. P will have a location. To that location itself, we are pointing another variable. That is second method. Next, third method, we will use a pointer. Using that pointer, we will be performing the swapping operation. So I think this question has been clear now. So you have raised a question regarding that pointers. Somebody has asked a question like that. Int, what it mean? Int and of R equal to B. What it means is that R is being B is being renamed as R. That's the meaning of this. So it's clear, I think. The second part. So any doubt regarding this? Hello?
No, sir. I think we are good.
No doubt. We'll continue.
Yes, sir. Yes.
Okay. Next thing, pointer to pointer. That's another big jargon for students. So what is this pointer to pointer? A pointer, normally pointer is used to store the address. So if you want to create a pointer, let's store another pointer. That's a pointer to pointer. A pointer to a pointer is a form of multiple indirections or chain of pointers. It's a jargon. Okay. Normally a pointer contains the address of a variable. Okay. When we define a pointer to a pointer, the first pointer contain sorry, contain the address of the second pointer, which point to the location that contain the actual value. That means we will take an example. Okay. So I have created a variable num. It contain address value 10. Okay, its address location is 1000. I'm going to create a pointer variable. Pointer variable is being created ptr1. Okay, it contains the address of this variable. Okay, 1000 it contains. That's a normal pointer. Still now we have been talking about this pointer. We will be creating the pointer in star ptr. It will contain the address and of num. Simple. Next, I'm going to create another pointer that will contain the address of this one. That means ptr2 contain the address of ptr1. But ptr1 contain some other address. That's the thing. So that is pointer to pointer. Simple thing. So the ptr2 is a pointer to pointer that is pointing to a variable that is also a pointer. Okay, that's a pointer to pointer. Okay, we will go for that. So I have created. So how to create a pointer to pointer? For that we will use double star. That in double star means p is a pointer variable, pointer to pointer variable, and p point to a pointer variable. That's a mean. Normally, what we write, if we write in star p means p is a pointer variable that contains the address of another variable. Now I am going to say in star p means p is a pointer to pointer variable that contain a pointer address. Okay. So we'll see an example. Int num equal to 10. Okay. So I'm going to create a pointer ptr1 equal to and of num. Next thing I want to store the address of that also. Then I will use a double pointer star ptr2 equal to and of ptr1. That means ptr2 will contain the address of ptr1. ptr1 will contain the address of. So if you write ptr2, you will get the value of ptr2. ptr2 contain ptr1 address. Star ptr2, we will go for the num1. Okay, num1 will explain like this. Okay. I created two pointers. Int a equal to 10. A have an address location 1000. Okay. I created another pointer variable in star ptr1, and I'm going to store the address of A. So A will have the address 1000. Okay, it automatically it will have an address location 2000. Okay, I am going to create another pointer star ptr2, and I'm going to store the address of ptr1. What it means is that ptr1, ptr2. So ptr2 will have an address location 3000. If I simply print ptr2, what we will get? ptr2 will contain address of ptr1. It is 2000. You will get 2000. Okay. So if I use star, then what it means? ptr2 will contain address location is 2000. 2000 will contain what? Address location of 1000. That 1000 will be printed. Value will not be printed because we have not reached up to this point. We have reached up to this point only. ptr2, simply writing ptr2 means it will retrieve the address location of this value. Okay, this ptr2 have the address location 3000. If I am writing star ptr means we will come to this location. Okay, it is 3000 is ptr2 contain 2000. It's 2000. 2000's value. 2000's value is 1000. Okay. Suppose I write like this: star PTR2. What it means? PTR2 will have PTR1 address. PTR1 will have, so we will reach PTR1. PTR1 will have address of 1000. Again, 1000 will have address of 10. So like that. It's just a connection. We can increment that to any number of stars. So what it means is that pointer to pointer means a pointer variable is pointing to another pointer. So we can get the value like this. So normally this type of question will be asked. So that's the relation between pointers and pointer to pointer declarations. Next, memory management. Memory management. Actually, in CPP we using for dynamic memory management we use malloc, cloc like that. So such things how we can do in CPP. Memory management is a process of managing computer memory, assigning the memory space to the program to improve the overall system performance. That's the memory management. As we know, the array stores homogeneous data. So most of the time memory is allocated to the array at the declaration time. So I'm creating an array int a of 10. It will be created. Sometimes situation arise when exact memory is not determined until runtime. So such situations normally occurs. To avoid such situation, we declare an array with maximum size, but some memory will be unused. That's one technique. We will be normally using that technique. We will be creating, I want to read a name. So I will be creating an array of size 100. So it's a lot of wastage is there. So how to perform memory management? So in C language, we use malloc, calloc like that. In the case of CPP, what we use is we use two operators. Unary operators are there, new and delete. These are the two operators using which we can create memory and delete free memory. So we will use these operators, new and delete, for creating the memory. The new operator is used to create the object, while delete operator is used to delete the object. When an object is created by using new operator, then the object will exist until we explicitly use delete operator to delete the object. So throughout the program, it will be there. Therefore, we can say that the lifetime of object is not related to the block structure of the program. So normally when we are creating a variable, its lifetime will be within the block. But in the here, it will be throughout the program. Okay, this is syntax of new operator. So I want to create an integer variable. Normally we will create the integer variable in B. So I want to create an integer variable. So using this new operator, then I will write like this: int star b equal to new int. This is the format. New format is like this: pointer variable equal to new data type. So if you want to use the new operator, you have to use the pointer. That's why it is connected in this module. Okay. So new is simply used to create a memory location. So how to create that? This is the format. We have to use a pointer variable for that, equal to new data type. This is the format. So I'm going to create an integer variable. Integer variable. Then I will use an integer pointer in star b. Then b equal to new int. That means my integer space will be allotted. Why we go for this? We can simply write int b. Same thing we can use using this memory management. It's not useful here, but when we take the array, okay, in star C, I want to create an array of 10 size. Okay. Then I can use like this: C equal to new int of 10. Here this value can be changed. Block of memory is being created. This is the format for new operator. Okay. Next thing, delete. Delete means delete B. Simply you can delete the variable by using B variable. Delete array, if it is array, delete C off square bracket. Within the square bracket, you can delete the. So this is the two formats, new and delete in Civil. Okay. So new is used to create the variable, same as malloc and calloc, and free is, instead of deleting the variable, we will be using the delete operator. For that, it will return this new and delete. It will return a pointer variable. Okay. So this is the format. Next, we will see an example. Okay. So you have studied, I think, structures. It's very simple. So I have created a structure variable, student. Next thing, I want to access a structure variable. Normally, structure variable access using structure variable will be created for accessing the structure. Okay. So I created a structure, student, stud. Okay. So how to access the structure variable? I will be using the dot operator. So dot operator will be used, stud dot. Here I want to use roll number. Okay. So instead of structure variable, why can't we use a pointer variable, structure pointer? So how to create a structure pointer? Structure pointer is same thing. I am going to create a structure pointer. So I created a structure pointer, student, star stud1, star stud1. So you should be clear that is the structure pointer is not used for storing the address of some storing the address of its one structure. It's used to store the address of another structure. Okay, so stud1 is used to create the address of stud. So instead of stud, I can use stud1 here. So normally we will use dot operator for accessing the variables, but here we have to use the arrow operator. So arrow operator will be used here. Roll number, stud1, roll number, stud1 name. So only difference is I had to use the arrow operator when we are using the structure pointers. That's only difference. It will be executed. So it will be printing the values stud1, roll number, and name. So we can see that output. So roll number 12, then name. So only difference is that when we are using a structure pointer, we have to use this arrow operator. Then it should have an address. Here I have used the address of stud. Stud address has been copied to stud1. The same stud, I can use stud and stud1 both for accessing that structure. Okay. We'll see another example. So here, write a CPP program with the following requisite. Create an array of pointers. I want to create an array of pointers to object with class name person. So I have to create a class name person. Okay. The class person has a single data item name. Okay. The class will have a single data item name which hold a string representing the person name. Okay. Two member functions, set name and print name, allow the name to be set and displayed. That's the first. I want to create a class name with a data type name in it. So I have to create two functions, set name and print name, for processing that class. Another thing is create an array of pointers. I want to create an array of pointers for access, array of pointer to objects. So normally when we are accessing the class, we will be using pointers. We will be using objects. So here I want to create an array of pointers. Okay. We will see the example. So I created a class. Okay, class name person I created. Then name is there. Then two functions are there, set name and print name. These are the two functions I created. Then I'm going to use the person, the set name function. Set name function is copying, user is going to pass a name and it will be copied to this name. Here we are using another keyword, this. This keyword is used to get the current object. It's a special type of object. It point to the current object. I have created a point object. Okay, this is my object P1. Then instead of P1, I can use this. Both this and P1 are pointing to the same location. Both indicate the same thing. That's this. Okay. So here, why I use this is because the name is here. Name is here. Both are names. That's why I used this of name. Means this of name is this name. It's been copied. So this is another keyword. It indicates the current object. Current object is this. It's a pointer. That's why we are using again arrow operator. In the case of pointer, we will be using whole arrow operator, not dot operators. Okay. Next, I've used a function print name. That name is been printed. We'll see what it happens. Okay. I created a person class. Simply I created a person class. Enter the name. Name is been entered. And it is been entered to T. Then it is been passed. This value is been passed to the function set name. Set name is been passed. So this value is been copied to this. Then it is been printed. It's a normal class. Next thing, I created another class, another object of person Q. So instead of accessing using this Q object, I want to use it using a pointer variable. Okay, so next thing I created a pointer variable person star R. Then instead of Q, I'm using address of Q. Address of Q is been passed to R. Same thing what we done in the structure. Same thing. Only difference is here it is a class. So I'm going to use this R operator for accessing the functions. Okay. Again, if it is a pointer that I can't use dot operator, I have to use the arrow operator R of set name, R of print. So here I have passed the address. Next thing, third option. Actually, we are why we are doing this? Actually, we are creating a point object, and we are creating another object and pointing this object to this point, this object. That's the thing. So we can directly create like this using the new operator. If we write simply star person star R, the memory will not be allotted. It is just a single memory location. It cannot store the whole data. Okay. For that, we can use a new operator person star S equal to new person. We will get the memory will be allotted for this S. Then we can directly use that S of S. So only difference is that in the case of pointers, we have to use the arrow operator. And one more thing is that when we are creating a variable, pointer variable, normally pointer variable is used to store the address, not the value. So most of the time you will be finding this example. You will be writing like this. Person Q, okay. Then person star R. You will try to access that. What happens is that memory is not allocated here. Here I am allocating the memory of Q. Like this. Statically I am allocating. Here I am dynamically allocating. That's a mistake. Normally students make this mistake like this. You will be writing like this person star R and try to access this. Error will happen because memory has not been allocated. So either you can use another object's address, or you have to create dynamically you have to create the memory using the new keyword. Okay. Memory will be this is the concept.
Yes, sir. Yes, we have a question related to this example. Sir, Pooja is asking, when should we be using the arrow operators?
Arrow operators. When the object or the structure variable is a pointer, then we have to use the arrow operator. Okay. I have created in the previous example, I have created a structure. Okay. So this structure normally we will create like this: student stood. That's a normal variable. It's not a pointer variable. Then stood dot roll number, like that we will access. But I want to create a pointer variable. Suppose I want to create a pointer variable, then I can use this arrow operator. When we have to use, actually in this example, I have dynamically created the memory. So in the case of dynamic creation, I have to use the pointer variable because new operator will return a pointer only. So whenever you have to use dynamic memory allocation, you have to use a pointer variable. Statically, we don't want pointer variables. We can simply use a normal variable. Whenever you are using dynamic programming, or whenever you are running the program and at runtime, we have to create something. We have to go for the dynamic. Then we have to go for the new operator. Then return type of new should be a pointer. So we are forced to create a pointer variable. So pointer variable is created. Once pointer variable is created, you cannot use dot operator. You have to use the arrow operator. That's it.
Yes, sir. Sir, I think we are moving on to the last few minutes of the session. Yeah.
I think we will conclude. This is the main thing. I think I have come to the end. This is the two examples. So whatever we have covered is that pointer is simply just a variable that hold an address. That's the main thing. Okay. So it can be used in programming because it gives us so many advantages. In the case of arrays, we don't want to have the whole A. We don't want to write A of 0, A of 1 like that. We don't want to write like that. We can simply write as a normal variable. Then for dynamic programming, we have to use the pointers. Then we can increase the size of the program as such according to our requirements. So it's very easy thing. Only thing is we find it difficult when we see so many stars. That's the only problem we have. It's a simple thing. Star we indicate two things. If we are using at the right side, it means that we will get the address of that location and get the value of that value stored in that location. That's star. If we are using in the left hand side, it means we are going to create a pointer variable. That's the two things.
Okay, sure, sir. So shall we conclude the session? I think that's it, right? We haven't got any questions. Yeah, so I hope we don't have any more questions here.
Okay.
So the concept of pointers being one of the most confusing, maybe one of the most challenging concepts for the students, I think it was explained in a very clear manner from the scratch itself. So I hope the session was very useful for all the attendees, and let me thank Sandeep sir again for giving us such a crisp presentation on the fundamental concepts of pointers. Thanks a lot, sir.
Okay, thank you.
Let me thank the attendees also, and please ensure that while you are leaving the session,